Welcome to Show's classes. Today we are going to be dealing with some linear analysis of least squares and how deleting an observation changes data handling. We'll define a data matrix. We will use a Frisch-Walk to obtain the first two columns of the least square coefficient vectors and do many such processes that will make such a complicated process very easy. You can WhatsApp or call it as the given number for any doubts or questions that you might have, or for full videos on our courses. Now let us first read the questions that we have. A common strategy for handling a case in which an observation is missing data for one or more variables is to fill those missing variables with zeros and add a variable. Let's start again. And add a variable to the model that takes the value 1 for that one observation and 0 for all the other observations. Show that this strategy is equivalent to discarding the observations as regards the computation of B, but it does not have an effect on R square. We need to keep this in mind. We also need to find whether the special case in which x contains only a constant and one variable. We also have to show that replacing missing values of x, small x, that is, with the mean of the complete observations has the same effect as adding the new variable. Let us first define the data matrix. The data matrix can be defined as follows: x equals to small I x 0 1 0 1, which equals x1 0 1, that is x1 x2, and y equals to y0 yn. The subscripts on the parts of y refer to the observed and the missing rows of x. Now we will use a process called Frisch-Walk to obtain the first two columns of the least square coefficient vector, that is b1 equals to x1 dash m2x1 whole inverse x1 dash m2y, and now multiplying it out we find that m2 equals an identity matrix now x1 dash m2 x1 equals to x1 dash x1 minus x1 dash 0 0 0 dash 1 into x1. This just draws the last observation, that is x1 dash m2 small y is computed likewise. Thus the coefficients on the first two columns are the same as if y0 had been linearly regressed on x1. The denominator of r square is different for the two cases. For the first strategy, the mean of the n-1 observation should be different from the mean of the full n unless the last observation happens to equal the mean of the first n-1. I know this step is very confusing, so I've written down whatever I've said beforehand. Let's write this as strategy 1. Now for the second strategy, we have to replace the missing value with the mean of the other n-1 observations. We can deduce the new slope vector logically. Now let us use the process that I mentioned earlier. Using Frisch Wog, we can replace the column of x's with deviations from the mean. Which then turns the last observation to 0. Thus, once again, the coefficient of the x equals what it is using the earlier strategy. The constants term will be same as well. With this, we come to an end of another great video. Please like and subscribe to our channel of Sorcerer's classes. Also, don't forget to click the bell icon. You can contact us at the number 9836793076 using WhatsApp or direct call for any doubts or queries that you might have, as we'll be here to help you. You can also contact at that number for more full videos on our courses. Thank you for watching. Have a great day.